Hey everyone, this is Eugene, and today we're gonna record another video of live contract reviews, and we're gonna review two contracts. One is our attempt at a new NFT standard, and another one is a contract by Matt, which is a market that would use approval system from the new NFT to try to actually sell tokens. So let me start my C line. Cool. So first, I reworded all changes that Matt did to the simple NFT. So it's one that is currently up on the core contracts in the PR. It uses a pre-release version of NearSDK, so it has some advanced features such as panic on default, but we still haven't published the contract. So the difference from the previous version, which had only one owner and it was following a fungible token pattern where you can only transfer token, you cannot give approval. So this one adds ability to approve a set of accounts per token. So the main structure is contract. It has two collections. One is tokens per owner. So it has a map of from account ID to the set of tokens that this account owns, and you can iterate on this, except we don't have view calls yet, but that's the goal. Second is you have tokens by ID, so from token ID to the token structure. It's not very optimized towards the performance, but it's somewhat working. Now, a token is a structure that has three fields. It has the current owner ID as an account. Metadata is what this token is about. And hash set, not a persistent hash set, of the account IDs that are approved. So every time a token is deserialized and pulled from the storage, you can see a list of approved accounts per this token. And this set is limited by the gas, so you cannot really like add too many accounts, but we probably should limit it to, let's say, 10 accounts at most or something like this, so 20. And finally, three other fields. So the token contract or this NFT contract has the owner, so owner can mint new NFTs, and it has total supply. The total supply is the number of tokens in the collection. We don't really need this because we can just take this map out and get the links. So we can probably remove it. And amount of storage that you need to mint a NFT. And this is needed for some basic storage management, which we need to talk about. So when you initialize the contract, you provide some defaults and it takes the owner ID. Next thing you do, you measure the cost, the extra cost that you would need per token when you mint a new token. As you can see, there's no real storage management per account or per other users. This is because the storage is fully paid per token, is fully paid by the owner of the contract. So when the owner mints a new NFT, the owner pays for the storage of this new NFT and everything except for the approvals. And we'll talk about storage management of approvals when we talk about implementation of this. Now, in order to Since the owner account ID can be shorter than 64 characters, when the token is transferred, the new account ID may be longer than the owner's account ID. That will increase the amount of storage required for this token to be stored. You may see that the token has a fixed size except for the account ID, and ignore approvals for now. Metadata doesn't change. At least in the current implementation, metadata is fixed. The account ID can be variable. So what we need is we need to calculate the worst case scenario in amount of storage that is required to store a 64 character account ID. To do this, we measure the initial storage, then we create a new unordered set with the unique prefix. Unique prefix right now is a fixed size of 33 characters. Tokens per owner is inserts this new longest account ID and this a new unordered set. We don't insert the new token ID, which will be added later. What we do, we say, okay, so what is the tokens per owner entry in bytes? So this is how much it's gonna cost to insert one unordered set. We measure this as well. We measure how much you need to pay when you change ownership from a default owner, or like from a current owner to the 64 characters. So this is the difference between the lengths of the accounts. And it means the extra storage in bytes is something like this. And you will see how it's used when we mint a token, which is the next thing we do. Then we clean up storage. So we remove this unordered set from the existence.
Will we talk a little bit more about how you said metadata is set per like the same for every token? That's the expectation.
It's fixed per token, which means you, as a owner, once the token is created, or as the new owner, you cannot change the metadata, so it cannot change the storage size.
And I missed it being measured. That's not part of what's being measured in measurement token storage cost?
Yes,
or
this is going to be measured separately. So it's measured in mint. The mint function is when you want to mint a new token with the token ID and the metadata. You cannot give it directly to someone, so you'll first, as an owner, receive it by yourself. So we assert that you're the owner, which just checks that the predecessor matches. It's a payable method. We start by remembering the current storage. So we create a new token where you are the owner, a metadata is set, and the list of approved accounts is empty. Now we insert this new token into the tokens by ID. So we insert a new token into the set. If the token with this token ID already exists, we say, well, no, you cannot recreate a new token with the same token ID. Now we add it to the list of tokens owned by the given account. So owner now owns this new token ID. The way it works, we get the set with a unique prefix and we insert a token ID into the set and we save tokens per owner now. We increase the total supply by 1, which is not necessary because you can derive it, and we measure how much bytes we spent on this operation. So we say we actually spent, we increased storage by this given amount by doing 2 operations right now, adding a new token into storage and adding the token ID into the ownership of the like into this own tokens by the contract owner. Plus, we use this extra storage in bytes that we measured originally in the constructor to compensate for the difference in account lengths, and potentially a new set have to be created by the new owner of the token. And this is the amount of storage in bytes required for this token to be minted. And there's a helper function that's saying, basically take the attached deposit and refund the rest. So keep the tokens that needed to increase the storage and refund the rest. And that's pretty much it. So this is how you mint it. So token ID is measured twice in the insert, in the storage. Then metadata is measured as well. And the only difference is like this account links difference plus the like a new unordered set difference in storage that we measured originally, which means now if this token is transferred, you basically don't need to cover storage because it's already paid for by the contract owner, by the minter. Does it make sense? The logic behind the storage?
Mostly. I feel like I would want to squint at it a little bit longer to be fully satisfied, but we don't need to do that here.
Cool. Yeah, I think it, well, I also haven't wrote a test for this, which is probably would be a good idea to just make sure we're not missing any bytes. Now we have ability to mint new tokens. So basically, let's say we have a token and we have a methods in a core token core, NFT token core trade interface that defines how much, well, like what methods needs to be implemented for the core standard. So it is similar to fungible token in terms of what it is, except we have a new extra field on a transfer, which saying enforce owner ID. This is what we talk about security of the approvals. And same method is on transfer call. The reason why you want to enforce it is because the predecessor might be different from the token owner, because predecessor can be an approved account that has ability to send this token, but this predecessor is not the owner. So we need to know who is intended owner to avoid some race condition security. Now we have three methods that allows you to approve an account ID for a given token, revoke the account ID from a given token, and revoke all accounts for the given token. And these are two. One of them is number of tokens, and second is give the token. And this one also returns the list of approved accounts because it's part of the token now. We also have token receiver. So this is not really implemented by this method. And it uses bool to say if the token should be returned. So to match the idea of fungible token so far. So it's essentially saying you should return one token back to the sender. So like,
And
let's
just
say
a note that the current discussion around the NFT standard, this might end up requiring a panic rather than returning
the
pool.
panic is a worse idea than returning false. And I commented on the reason why. Main reason is panic is much harder to return if you need to save your state. So if you're a receiver and you want to do some actions, let's say you want to do another call on the receiving side, then you have a callback. And in your callback, you may want to save your state. If you have to return a panic, then you cannot really save your state, because at panic, the state is not saved. That's why returning true as a secondary option is a better idea. True or false, doesn't matter. Like, we can change it. It has an extra field that is not on fungible token. It has a previous owner ID, and the previous owner ID is the account that was actually owning the token, because the token can be sent by a approved account instead of actual owner. And we have a resolver. So overall, the logic is fairly simple. For transfers, it is somewhat similar to fungible token, except we need to handle storage refunds for the set of approved accounts. And here's how we do this. For when we call internal transfer, if it succeeds, not panicking, then it would return the previous owner of the token and the previous list of the approved account IDs for this token. And for NFT transfer, so for the simple transfer, we just refund this list, the storage for this list, back to the previous owner. So there is no storage management standard here, which may be a problem, but for now we didn't implement it, but we can actually implement it.
So just to double check, internal transfer transfers the token to the new owner and clears the list of approved account IDs, since the new owner presumably doesn't want them. And since it has cleared the storage, it can refund the deposit for that storage to the previous owner.
Correct. Now, NFT transfer call. Now, this call is a little more complicated. And the reason for this is we actually need to handle a refund of approved account IDs only after the transfer was confirmed. Because if the transfer was canceled by a receiver or receiver panicked, it means the approved account ID set has to be returned back to the original one that the owner has set, instead of being the one that was reset during the transfer. So during this transfer, we immediately transfer the token to the new owner and clear the list of the approved account IDs. So then now the contract to which we transfer in these tokens is the owner of this account ID, or of this token ID, this clear set of the approved account IDs list. So there's no other accounts that can interact on this. If we refund the storage immediately for the approved account IDs list, and later the transfer is reverted, it means we out of storage, so we cannot set it back. So the list has to be temporarily kept in memory in case we need to revert the transfer. And we cannot refund tokens for this list because the transfer have not been finalized yet. So the receiver have not finalized the transfer. Now, so it calls a promise on the receiver, and then it calls a callback. So before we go into how the approvals works, let's actually look what we do at the resolver. So resolver is somewhat similar to the fungible token one. So we check the promise is successful. We say whether we should return the token back to the sender or like back to the original owner. If we don't need to return, we say the token transfer was successful and we refund the list of the approved account IDs. So this is kind of the same we doing that we did at the regular transfer. And we say, okay, the transfer has completed. Now, if we have to return it, for example, promise failed, or it returned returned true, so we need to return the token. Then we get the current token. If the owner has changed during the moment after we initiated transfer call, it means maybe the receiver, the contract already transferred to somewhere. We cannot do anything. It means the refund cannot be completed. So we refund the approved account storage again. So it just calls this method again and return true. So the token owner is not owned by a receiver. We can't do anything. Otherwise, let's say the token was burned. Well, there's no ability to burn, but let's assume it's possible. We also give the money back and say, okay, done. It was taken. Otherwise, we send a message saying, okay, we're going to return this token ID back to the from receiver back to owner, to original owner. We remove tokens from the new owner. We added back to the original owner. We set the token ownership. We refund the list of the approved accounts for the new owner. So let's say a new owner actually added an approved account and paid tokens for this. So we give the money back to the current new owner who should refund it. Then we change the list and we don't refund it, and we insert it back. So that's the logic. It's a complication around storage management that we need to keep track of. It's a complication around approved account IDs list that we need to keep track of and stuff like this. Okay, so let's quickly go through approvals. So here's how it works. So we get the one Yocta for the approval. We say the token is getting the token. We verify the ownership, so only the owner can add new approved. So a marketplace cannot add another approval. We get the account ID and the storage needed for a new account that you adding. Then we say, okay, go insert this. And if the approval was already there, then we just return that it was there. You don't need to do this again. If it's not there, then we refund the deposit. Oh, we actually take your deposit. Oh, I guess the problem is I didn't do this. So you need to return money and it cannot be one Yocta. Sucks. Because it has to be more than one Yocta. Or at least one Yocta. This one can be one Yocta. So we take money for the storage used. If you already have a token, then we just refund everything. We can also panic here. It will automatically refund the money. And revoking works the following. So we get again the same checks around the ownership. Now we remove this account ID from the list of approved tokens. If we successfully removed one, then we need to release storage. So we get the storage for the removed account in bytes, and we refund this amount to the predecessor, who is the owner actually. And we save this token and return true. If not, if such account didn't exist, we just return false. In our revoke call, does the following. It uses this magic method of refunding all accounts ID, then we clean it up and we save the token. Where should we dive? Okay, so bytes for approved account ID is the length of the account plus 4 for the length of the board serialization. Refund list of account ID, it calculates the sum by calling this method on every account ID from the set, and then refunds this amount based on storage released. And finally, the internal transfer, how it works with approvals. So we get the token, we break the token into owner ID, metadata, and a set of approved account IDs. We verify that you have ownership or access by checking if the sender is not the owner and the approved account ID list does not contain the sender, then we panic. If we need to enforce the owner ID, then we do the check that the owner is exactly the same as one that is enforced. Then we say you cannot transfer to the same receiver. Then we'll log that we're doing a transfer. We remove owner from a current one of token from the current list of tokens for the owner and give it to receiver. Then we create a new token with the owner of a new receiver. A list is empty and the same metadata, and we reinsert it back to the set. And if there's a memo, we drop the memo and return the original owner. So that's pretty much it for the NFT standard. There's no storage management that is following the standard. So because the list of approved account IDs is currently tracked and refunded on demand to the original owner. And only the account can actually initiate this transfers. So we have 10 minutes left, and let's actually look at the simple market that Matt implemented. The contract has the owner ID and a list of the tokens on sale. Contract and token ID is a string for some reason.
Yeah, it's a lookup basically to say that the market symbol can basically be used by any contract and token for the contract. So it's just it's a concatenation with a colon.
Sure. So you initiate the contract, and then there's a method to add a listing, which has the contract ID, the token ID, and a price. And you're saying on behalf of which account you want to do the sale, which probably should be valid account ID here. So you get the deposit. It needs to be at least 0.1 near to list, I guess, to cover storage for the listing. And like do some Sybil resistance. Contract ID is the token contract ID, and owner ID is who is calling the sale. Well, why? Okay. Okay, so if you call in on behalf of, then you can like pretend to be an owner, and you kind of paying for the storage, but okay, beneficiary is the predecessor. Got it. So price and the deposit is how much tokens you paid for this listing. Price is what you want to get for the token. Now you have removed sale that removes the given sale. It checks that the owner is a predecessor, so only the predecessor can remove sale. And it refunds it for some reason to the owner instead of beneficiary. So it's a bug.
Should the owner ID, should the on behalf of, like, does this mean anyone can list an NFT as being for sale?
Yes. Yeah. So far there's
Should it
doesn't check the ownership. So I feel like there should be like at least some either a way to verify the ownership, so you can at least someone's token for sale.
Well, it should be owner or approvers, or like approved, whatever we call them,
Yeah.
approvals,
Yeah.
approved
Yeah.
accounts.
But that's fine for
which
now.
would require a cross-contract call,
Yep.
which means it could change in between.
Yes. Yeah, that's a problem with approvals. Like approvals cannot be verified. So this is as good as rely on a cross-contract call.
The only the only way to solve the problem as I see it is if the call originates inside the NFT contract and the token ownership is enforced, and then the NFT contract in a very standard way calls the market contract. And this could be done in a standard way, and it could actually be paired up with the approval. So it could be like some method, for example, like approve and add sale to market contract. And then what would happen is you check token ownership, you add to the approved, you add the contract ID to the approved IDs, and then you make the cross contract call, which adds the sale. So it does it all in one shot.
Yeah, you can do unapproved, so you can at least prevent some listings. It's still at any moment listing can become invalid because the approval can be revoked, but we also can do well, we cannot really do revoke callback because it's many of them, while approval is one-to-one. So we can only add approvals, but then what's the point if you cannot do revokes? Plus there still can be like cross-contract call for this. Anyway, so let's look at the purchase. So you have a contract ID, a token ID, you pull the sale, you get the how much it's paying. So the price should be exact. So you pay in exactly create. You actually don't need to use a valid account ID here, so that can be just accounts for the interface. So owner ID.
Oh yeah, just to clarify, so when I'm specifying this external transfer NFT transfer trait down at the bottom, I can just use account IDs and just ignore the whole valid
Right.
account ID thing.
Yeah.
So valid account IDs, essentially, they should only be used for external, the very first external call coming in, right?
Yeah, but also you have the option here. I think it's better to follow this pattern, even so that deserialization potentially will work, so you don't care. So so you
yeah.
can do.
Sorry, this was a leftover, a little bit of kind of leftover code I had. Oh no, sorry, never mind. I understand what you're doing. I originally had a really terrible flow for the market contract, where I had the NFT transferred to the market contract and then transferred to the buyer. It was not optimal.
Yeah, that's the best. Okay, so you have a memo, which is again should be an optional string. You don't really need to pass it, but so you better do this. And you send in a contract ID, then a one Yocta, and paying for the transfer call and resolve. And on purchase, you remember the contract ID, token ID, the predecessor, but you already removed the listing. What you really need is a deposit for listing, unless you keep the fee. Maybe you just keep the fee. And on resolve, what you do is you actually forget to enforce that it's a private contract. So you probably want to do so some other contract doesn't call you. And then you got the token ID. So you check the result of the promise. So if promise is successful, but it's always successful.
It could fail.
It could fail at the transfer itself. So, you call it the basic transfer. Yeah, that's fine. Yeah, got it. So you paying but there's no sale already. You already removed the sale. Oh, no, you did not. I see. It means you can like try to purchase twice. Fine.
So okay, so there's a problem here. You can purchase twice in between promises, right? Like
Yeah.
okay, so you have to remove the sale and add it back.
Ideally, yeah.
If it wasn't successful.
Yeah, you can basically do this.
Just like you did with the approved account IDs.
You can log the sale instead of removing it. You can like say, oh, the purchase in progress. But in theory, if the sale failed, you probably want to remove the sale anyway because it's invalid now.
But what if the sale failed due to, not like due to sort
Not
of
enough
like
gas. Yeah, you probably want to attach gas fixed here so the sale fails before you initiate. So instead of paying prepaid gas, you just say, well, the transfer requires some near, let's say 10, just because it needs to do a refund. Anyway, let's see what you do. So let's say the transfer succeeded. That's then you refund to Well, that's actually not correct, because why beneficiary grabs both the sale and the deposit? Shouldn't beneficiary only grab the deposit, and like you should pay the owner? Like, what's the point of the owner? I guess I maybe don't understand the market.
Yeah, the deposit was just to pay for storage of storing the sale, right?
Yeah.
So you're
So
gonna
maybe you
pay that. Yeah, this part's not perfect.
something like this. So you pay the owner the price and the deposit back to the beneficiary or something, the one who listed on. Well, actually, I'm not sure who.
Oh yeah. Can I explain why I did what I did by
Yeah.
explicitly listing a beneficiary of the sale proceeds? So the beneficiary, so in my NFT example, I have like essentially like guest accounts and meta transactions, like basically sponsored transactions. So I have the NFT contract acting on behalf of a sub account. So basically the NFT contract is the one that made the the original sale deposit, and the NFT contract will take the sale proceeds, and then the NFT contract that I have, essentially it marks the sale price as basically funds that should be escrowed for the guest. So the guest, when the guest wants to like withdraw their funds, they can sort of take out that amount from the contract. I realize it's totally like not the best.
Now it's also a problem, because the beneficiary can set the price to whatever they want on behalf of the owner. So if owner approves this marketplace, then a beneficiary can list a token and immediately buy it and pay owner zero, or like very low price, like one.
Right. But the like again, the idea is that the
Yeah, so
NFT market
anyway.
is inviting these people in as guests. So it's like, I mean, it's you're describing kind of like a rug pull, right? Like, I mean, if they started doing that to their guests, then I don't think they'd have a very successful app. But
Okay, yeah,
I
so
get
the
the
idea
security.
is
It's a security problem.
fairly, so the idea is somewhat correct, except you cannot really trust the ownership that the listing still exists and stuff like this. And yeah, but the idea is the market would look something like this. So it will attempt to do the transfer on behalf of the real owner, the one who listed the token as an owner, and pay the owner instead of beneficiary. So beneficiary here shouldn't exist at all. And only maybe like doing the deposit, but the owner has to confirm the price instead of beneficiary. Either way, we're out of time that we wanted to allocate for this. So thanks for watching. Hope it was helpful to explain the NFT standard that we currently have, and we still keep iterating on this, but this is what we have so far. And maybe it makes sense to put the storage management into the standard, but since all operations still requires one Yoctanier for like every approval and transfer, then the storage management doesn't really serve the purpose here, such as it's required for like Sybil resistance. For this one, the main reason was to get the approvals covered, but we did it through just regular refunds. Okay, thanks, bye.
Thanks, Eugene.